Hey guys, sorry I couldn't be here with you today. Unfortunately, I have a doctor's appointment that I couldn't reschedule, so um, rather than just blowing off the day, I figured we'd take a shot at giving you guys a quick video to kind of help you through, and we can keep rolling. I figure today we'll give it a try, see what you can do. We can always regroup, and if I need to spend a little more time on it next class, no big deal with that. All right, today last class we kind of talked about triangles. We talked about how to classify them both with their angle and side length names. We also talked about the interior angles of every triangle adding up to 180 degrees. Okay. Today we're going to be talking about polygons, of which triangles belong to that group. Okay, a polygon is any closed figure with three or more sides. Okay, and here are several examples of different polygons. Okay, both regular and, you know, not. All right, next we have regular polygons. Okay, and what makes regular polygons special is regular polygons are those who have congruent sides and angles. Okay, and we have some images here. Here are several regular polygons, a square, an equilateral triangle, we have a pentagon, okay, and an octagon, and a decagon. Okay, that's just several names that, or several examples of regular polygons. Okay, if you guys take a look at the worksheet that you got that go along with your notes, okay, you have this table. Help you out here. Obviously, 3 sides is a triangle, 4 is a quadrilateral, 5 is a pentagon, 6 is a hexagon, 7 is a heptagon, uh, 8 is an octagon, 9 is a nonagon, 10 is a decagon, 11 is called an undecagon, and 12 is called a dodecagon. Okay, although the rest of them have specific names, anything past 12, you can just write the number and the letters GON on the end, and you're good. So a 13-sided figure would just be a 13gon. Again, there are names for them, but I don't really care that much about them, and I'm doubting you do either. All right. So in addition to the names and the diagrams themselves, we want to know the interior angles of those polygons. Obviously, we've talked about a triangle, every triangle having 180 degrees. So that's the interior angles of a triangle. Okay. Now, if we want to move on, we have our quadrilateral. All right. And we're going to use the same principles that we had in order to come up with the interior angles of that. We're going to look at the number of triangles. So I'm just going to take this one figure here. Okay. And I'm going to take these angles. We have 2 triangles now. So if we take 2 triangles times the 180 degrees, that's the interior angle of one triangle, we get 360 degrees. So the interior angle of every quadrilateral is 360 degrees. Okay? If we follow along with that same idea, we're going to pick one point. Okay? And we'll draw that over here, and we'll draw that one down there. Okay, and now we've kind of maxed out our opportunity. We have 3 triangles. So we're looking at 3 triangles at 180 degrees each. So we're looking at a pentagon having 540 degrees. Okay, now if you notice, however many sides we have 2 fewer triangles. So obviously a triangle has 3 sides. There's only 1 triangle in a triangle. Okay, if we look at a quadrilateral, there are 4 sides, but there's only 2 triangles. Pentagon, 5 sides, and only 3 triangles. Okay, I'm going to ask you now to pause the video, and I want you to try to fill in the rest of this table. Okay, when you're done, just click back on, and I'll have all the rest of the answers posted up, and you can see how you. Okay, so there we go. The rest of the group, they're the correct answers for the angles. So again, the interior angles of any polygon, we're looking at how many triangles can you draw inside. And remember, it's always going to be 2 less than the number of sides. So we want to say that the sum of the interior angles of every polygon are equal to 180 degrees times the number of triangles in the figure. Again, and remember that's always 2 less than the number of sides. All right, so again, that all deals with interior angles. Naturally, the next thing we want to talk about with polygons are the exterior angles. An exterior angle is just an angle that's outside the figure. Okay? When we talked about interior angles, we had to spend a bunch of time talking about the number of triangles and finding it from there. Luckily for you, when you're talking about an exterior angle, the exterior angles of any polygon, no matter how many sides there are, always add up to the same thing. They always add up to 360 degrees. So it doesn't matter if you have a triangle or you have a 100-sided figure. If you take the measure of the outside angles, it's going to add up to 360 degrees. Okay. All right. Now, that is important information, and you can use that 360 degrees to answer all kinds of questions about polygons. Okay? So if you look at the back side of the worksheet that you guys got to help you with your notes, we're going to go through several of these problems, and then you're going to finish the rest of them and do some classwork. All right, so what is the measure of the exterior angle of a pentagon? Well, here's your pentagon. Here's the exterior angle. It's this angle right here. Okay, all you have to do is remember how many degrees are there total in the exterior of a pentagon. And for any figure, it's always going to be the same. It's going to be 360 degrees. We're going to divide that by the number of sides, the number of angles that we're talking about. So in this case, it's 5. So the measure of one exterior angle of a pentagon is 72 degrees. Okay, moving along, we're looking at number 3. Um, a regular polygon, or which regular polygon has an exterior angle of 8 degrees? Okay, well, this one slightly different from the first one we looked at. This one we knew how many sides there were when we were looking at the angle. This time we know the angle and we're looking for the side. We're literally going to do the exact same thing. If we say 360 degrees divided by the angle, the exterior angle, we end up with a total of 45 sides. Okay, 45 sides on that figure, 45 gone. Okay, so again, all you need to know that exterior angle. Anytime it talks about exterior, you can just deal with it just the way it is. Okay, now if we look at number 5, it asks which regular polygon has one interior angle that measures 144. Well, remember, if we're looking at any time you have exterior angles, the interior angle right directly next to it and the exterior angle form a linear pair. They form a straight line. So in this case, if we want to know which figure has an interior angle of 144, we need to work towards that exterior angle. So we're going to say 180 minus 144, and we know that one exterior angle of this figure is going to have 36 degrees. Okay, we're going to then take that 360 degrees for the exterior, and we're going to divide it by 36. Okay, when we do that, we end up with a total of 10 sides, or a decagon. Okay, so any figure that has 144 degrees, as it's the measure of its interior angles, is going to be a decagon. Okay, we got a few more to talk about. What is the sum of the interior angles of a 24gon? Okay, there's 2 ways we can approach this one. We can think about a 24-sided figure and draw the little triangles that go with it. Remember, that's always 2 fewer than the sides, so that's 22 triangles that are going to fit into a 24gon. And from there, all we would do is say 180 times that 22, and we get our answer. Now, if that's something that doesn't resonate necessarily very well for you, there's an alternative. We can, again, think about the exteriors. All right, so if we take 360 degrees and divide it by the 24 sides, we end up with 15 degrees. Maybe. No. There we go, 15 degrees for one exterior angle. Okay, but again, we're talking about interior angles, so we're going to say 180 minus 15. We end up with 165. So A 24gon is going to have 165 degrees in each of its interior angles. Okay. And then from there, all we need to do is say 24 sides times 164 interior degrees per angle, and we end up with 3,960 degrees total. Okay, and you would have gotten that either way, whether you followed the way that you can see here or the um, 22 triangles times 180 degrees. It's going to be the same thing. All right. Okay, last one in this group. We want to know what is which polygon has an interior angle sum of 8,640 degrees. Well, now we really only have information about the interior angles. I mean, obviously, the exteriors are going to add up to 360, but that doesn't help because we don't know what one of them is, and we don't know anything about the exteriors. So, in this case, what we're going to do is we are going to use that idea with the triangles. Okay, I want to know if I have 8,640 degrees, how many triangles would it have in it? So we divide by 180 because every triangle adds up to 180 degrees, and we end up with 48 triangles. Okay, well, if we have 48 triangles, we always have two more sides than that. So a figure with 8,640 degrees of interior angle space is going to have 50 sides. So it's a 50gon. Okay. The last two that we're going to look at on here, just kind of gloss over. I'm not going to necessarily go through them all with you. This one, obviously, we have figure ABCDEFG. It's a regular octagon, and it asks you for the measure of DCQ. Well, DCQ is just an exterior angle. Well, we've already talked about how to find the measure of one exterior angle. Okay, if you don't remember, rewind and take a look at it again. Number 12 is a really popular type of question, one that you most likely will see on the SOL. All right, and it includes two figures kind of stacked on top of each other. Okay, and the trick to this one is to put this extra line right in here. Okay, so we end up with now instead of two figures stacked on top of each other, we can look at the top and then look at the bottom. Well, I'm going to throw an extra letter in here. Okay, and I'm going to call it S. So in addition to the figures that we already have, instead of just looking at PQR, we're looking at PQS and SQR. Well, if we ignore the bottom part and we just look at this hexagon on the top, if we want to find all we have to do is find the measure of the exterior angle of the hexagon, and then ignore that and look at just the bottom and find the exterior angle of the octagon. Okay, and then once you find that, all you have to do is add them together, and spoiler, it ends up being 105 degrees. So check it out yourself and see what you can do. Again, at this point, you probably want to pause the tape, okay, and then answer the questions that we haven't gone over, and then you can check it if you go back to the Google document, okay, where you found this link. Right, there is a link that says check your answers. You can click on that and it'll show you all the answers to the problems that we did and the ones we didn't do. Okay. When you're finished with that, you're going to work on the classwork, which back here is right there, page 394 to 395. You're looking at those problems right there. So you can either grab yourself a textbook and start working on those problems. You want to complete them in class, and if you want to do it on paper, you can do that and turn it in. And if not, you can actually, if you'd like, in this Google Doc right here at the very bottom, you can put your answers there. Okay, that's fine too, and just click turn in up here. Obviously, I'm not a student, so it's not going to say it for me, but for you, it should say turn in. You can just click that, and that'll turn in your answers. Okay. Last but rolling up next. Before the end of class, I say about 10:55. Again, you don't want to forget. You want to answer the exit questions for today, which what did you learn? What have you not yet mastered? And then I'm looking for the answer for number 20 in the classwork. Okay? And then last but not least, you have your little half sheet of homework. again, do the best you can with that, and we will meet back again on Friday, and hopefully we can clear up any misconceptions that anybody has. At any point, between now and then, if you have questions, I'll be here Thursday and Friday, so you feel free to stop in and, ask questions, or check out Math Tutorial in its new location of 701 Miss Compton's room. All right, guys. Well, again, I apologize for not being here with you today, but hopefully this video was helpful, and hopefully you were able to answer these questions. Again, we'll see you on Friday, and take care.